So I'm going to show you two examples of features from two past students that I have taught. Okay, both these students have gone through the exam board. Both of them got 10 out of 10 for analysis, and I really want to show you where I want you to put the detail there. So the features, they don't necessarily seem like you need to put a lot of detail into it, but actually the opposite is true. You are going to be spending quite a lot of time researching these, and the biggest mistake I see from students is they'll tell me what the feature is, they'll tell me why they're including it, and then they'll say I can code it because I found it on this app, and that's their justification of it being computable. Now that's not a good justification, and also it doesn't help the student to actually code it. So really, long and short of it, when you've worked out what feature you're going to include, when you've worked out why you need to do it, you then need to know how you're going to do it, and that how you are going to do it is essentially the computational justification that it can actually be done. Okay, so putting the time and effort in now just makes design easier, because when you come to write your algorithm design, you'll know exactly what it is because you've already done the research. It'll make coding easier because you've already spent a lot of time working out how you're going to do it. You worked out the algorithm, now you can just code it. So actually implementation becomes the easiest part of the course rather than the hardest. So let's delve into this student's work. So this student was creating a game where each level was randomized, and it kind of had a viewport where you can only see part of the map at a time. You can walk around the map and the screen scrolls. Okay, so his description and justification. Well, the description is really dead easy because he just said what it is. It's going to be a random map. There's not much more you can say about it. And then he says, why am I including it? Well, he's talking about the replayability of the game, giving new experience each time to make it fresh and interesting. That's his justification. That's why he's done it. Now, a lot of this would have come from his existing app research, because he's already looked at two applications which had random maps generated within them, and he's talked about why he's including it. So he's got that justification down. As a marker, I am allowed to kind of go back to that existing app research and actually pull out an additional research. So you don't necessarily have to repeat yourself. Okay, so don't feel the need to repeat yourself. I can go backwards and forwards to mark it. Okay, this is the important part though, the computable part of it. Now, I strongly suggest breaking this down into these subsections because it just makes it easier to mark it and makes it easier for you to write it as well. It makes you really, really focus on it. So what this student did was he based it on something called the game of life. Okay, so there's something called finite cell automata, which you don't need to know what it is, but what he's done is he's taken this algorithm, which is the basis of finite cell automata. He's then explained it and then shown how it links to it. So now we're going to look at one feature, okay, his main feature, but only one feature, and how he's explained it's computable. So he's talked about the original algorithm called game life algorithm. He's talked about how it works, okay? And you can see straight away, he's explained the algorithm. So what he's done is he's gone off, worked out how on earth he's going to make random maps, found out that it's based on this algorithm. He's then researched that algorithm, worked out what that algorithm does, explained it here. So here becomes the justification of why it's computable. And he's explained the algorithm. He's then talked about how he's going to adapt it, okay, to generate a map. He's got some sample code here, which he generated himself. So he wrote this code just to practice it. This is perfectly acceptable analysis, okay. In fact, I encourage it, because if you do like little code snippets to test out your ideas, well, you can then use that later on, can't you? Okay, it becomes the basis of your algorithm design, doesn't it? It makes life a hell of a lot easier later on. So doing little code snippets to test out your ideas is really, really good practice. And you can put it in here as justification that this actually can be done. Okay, and a caveat on that though, however, please don't write the whole thing. That's completely opposite of what you're trying to do. You're trying to prototype an idea. You're not trying to code your system at this point. Okay, to make that really clear. Anyways, so he's shown out example code, how it might be done. And here he's got some more sample codes and explaining it. So I'm not going to delve too much into this. And here is his prototype code of his initial map. This is what the map it generated after its first iteration. Here's his second iteration. His third iteration, you can see now it's starting to look more like a map. So the kind of circle areas, maybe are the areas you can go or not go. It doesn't really matter. Okay, but you can see he's got these little islands appearing in his game, and he's then tried it out. He played around with it, and he's got an algorithm. He's referenced his research as well, which is also really important. But this was a complicated part of his application. It was the hardest thing that he had to code, and it is a really hard algorithm. This is the complexity of his algorithm, of his whole system. Sorry. And it makes sense for him to spend a lot of time researching it. Okay, when he did this and he made this prototype, he knew exactly how to actually do it when it came to designing it and came to actually coding it. Okay, so, and he could use a lot of that prototype code he did to kind of speed up its implementation later on. So he spent the time in analysis, long and short of it. He spent the time in analysis, and it just made the rest of the course easy for him. Okay, so that is really important. Let's look at a second example. Now, this one was a kind of film recommendation system where you could rate a bunch of films, and based on your ratings, it will pick which films you like. A bit like how Netflix will do it and YouTube does it and things like that. Obviously, very, very simple though. So, one of the things he had to do was rate a film. Now, that seems really simple, doesn't it? Because you have like stars on the screen, you press it, done. But how do you code that? How do you code 5 stars on the screen? How can you select which stars you want? How do you do that? There's the justification, isn't it, ladies and gentlemen? So, he's explained what it is. Like I said before, notice he's broken up in the same way the other student has. I generally encourage you to do that because it just makes it easy for you and the examiner and everybody as it goes on. So, here's his justification of why he's done it. Now, he's gone into a bit more detail than the other student did about why he's got a justification. So you can see here there's a bit more detail in there. So to be able to suggest films, the user and application will need to build up an understanding of the types of films the user enjoys, allowing the user to rate the film out of 5 stars, gives the application quantifiable input to the algorithm that will compare films like it and decide whether to suggest. So he's saying why he's including it. Bang on. And here's his justification. Now what he's done is he's researched, well, how can I do stars on the screen? He's decided to use something called Qt5. Now, this is a Python library which you can use. You can get it on other programming languages as well. But it's a Python library which allows you to create user interfaces. So it's a bit like tkinter. I personally prefer Qt5. I find it easy to use and more flexible because it's got a graphical user interface you can use to kind of create user interfaces with. But what he's done is done that research, found out what it is. Okay, he's found some example code called star delegate, and he's referenced it. Okay, and he's then kind of gone through it. He's shown what that code looks like. Now, this code is not Python. Okay, it is in a different language. By the looks of things, it looks like it's C++. Yeah, it looks like C++. I might be wrong on that one. Maybe C#. I don't know. Can't tell, actually. The star kind of gives it away, makes it C. If I'm wrong on that one, please sue me. Please don't. I'm joking. It looks like C++. It looks like C++. Anyway. So he's got this sample code in there to show that this could be done. So he's shown it's computable. It shows really clear research. So what he's then got to do is actually turn this into his own version in Python using Qt5. And here you can see he's got his links as well. So he's referenced his research. And this is what I'm looking at. So let's summarize the whole thing. What are we looking for every single feature? We want to know, and let's show his next one, a description of that feature, a justification of why you're including it, and a computational justification which says how that is going to work. And that has to be research. You have to find out exactly how to do it. Do not be vague at this point. You must be detailed because it just makes life easier and it guarantees you 10 marks in analysis.